Right. All right. Hey, everyone. First stream ever. Thanks for joining. How many people we have here? Okay, 26. Nice. Can everyone hear me? Say yes in the chat if you can hear me. No? Hello? Okay, cool. Wow, the chat's delayed. Hey, everyone. Thanks for joining. Thank you to everyone that's been following me over the past few years. Really appreciate your support. This YouTube thing has been awesome. Yeah, first live stream. We'll see how it goes. All right, so Mojo. Mojo, I did a video about it probably, I don't know, 6 months ago. And it was in a really incomplete state. It wasn't ready for prime time at all. The development of Mojo was it seemed to be focused on speeding up this number crunching, right? These low level matrix multiplications that AI and machine learning are so dependent on. And obviously they did this amazing demo. If you all have seen it, where they demonstrated like a 60,000 times improvement over Python for matrix multiplication, which is incredible. But then when you go and try the language, it's kind of restricted to a Jupyter notebook. So you couldn't actually at the time download the SDK to your local machine and kind of play with it on your local machine. A few months later, they released an SDK, but it was Linux only. And I tried it. So I grabbed an EC2 instance and tried running the SDK locally, and I could not get it to work. And I asked for some help, and it turned out to be, it was blamed on, I guess, not having enough memory on that machine. But I was a little bit skeptical of that. Long story short, they released a Mac version a few days ago, and so I gave it a little try. So I wanted to share what I found with all of you and maybe kind of test out some more things that I haven't tried. So yeah. For those of you that don't know about Mojo, just taking a step back a bit, the goal, so Python is the king of the data science ecosystem and pretty much undisputed. But there's a few problems with Python. One is that Python is slow, right? I don't think anyone's going to dispute that. The second is, and that's kind of related, is because Python's slow and machine learning and data science are computationally intensive, that means a lot of the low-level operations are written in C. And then there's hooks that are provided to these Python APIs that data scientists call in their application code. And so there's two problems with this. One is you have to decide, okay, which parts of my program or which part of my stack is performance critical, right? So that's a decision you have to make. And then the second problem is, and you can argue that, my application code, the stuff that's actually running in Python is not performance critical enough for kind of the slowness of Python to be a detriment to the program, because all the computationally intensive stuff is in kind of the C libraries. And there's two problems with this. So one, you have to decide where that line is, right? You have to decide, okay, this part of my program is not computationally intensive and this other part of my program is, and drawing that line is not really, it's not always a clear decision. And the second problem is your stack is not isomorphic. So that means if you have a data scientist that's only worked in Python, they're probably never going to be able to contribute to a C code base that's doing the low-level computations. And so, yeah, that's the other problem. Mojo aims to fix both these problems by having a language that is performant, no garbage collection, compiles the machine code, runs on bare metal, yet is a superset of Python. So you can actually technically copy and paste Python code into a Mojo file and it should work. That doesn't work right now quite yet. There is a Python integration that maybe I'll get to, but that's the long-term vision. So now that we've set the stage, Emacs, yeah. Okay, so one of my gripes with the current release is there's only a VS Code plugin for syntax highlighting. So I am relegated to using VS Code. I have the Vim plugin, so I'm not feeling too out of the water, but yeah, we're gonna go with it. Mojo's async. Yeah, I haven't done async stuff yet. We're not gonna get too in depth in this one. We're gonna kind of, you could argue Mojo's like the main value prop for Mojo is this low level SIMD computation. So you have arrays of numbers and you're doing matrix multiplication can be optimized at the CPU level by multiplying many numbers together all in one CPU cycle. That's kind of the basis of a lot the concept of SIMD, and something that Mojo leverages at the low level to speed things up. That is not a world that I live in, and probably most of us live in. But I'm kind of looking at Mojo from the perspective of a general purpose programming language, and that's not what Modular is marketing this toward, right? They're marketing it. Let's look at the website. Let's see. Yeah, the future of AI development starts here. They're not even trying to market this as a general purpose language. But if it becomes a good fit for AI, it's hard to imagine folks not starting to adopt it for other things too, right? If the vision comes to fruition, it's reasonable to assume that you could do anything with it. It may start out, as many languages do, in kind of a niche community like AI. I don't know if you'd consider that a niche community, but yeah, so all the marketing material is kind of geared toward AI, but we're looking at it through the lens of an average Joe developer like me. Memory safety. So yeah, I didn't touch on that. So there's no garbage collector. It aims to have Rust-like semantics for borrow checking. So you'll see in a minute. But anyway, yeah, it aims to be memory safe. I don't know if there's kind of like Rust has interior mutability for things that are memory safe but will not compile as far as the borrow checker is concerned. I don't know if there's an analog to that in Mojo. I guess we'll have to see. Even if there is, I'm pretty sure it's not implemented yet. I could be wrong about that. Def and function. Yeah, we'll get to that in a second. Thank you, Houston. But yeah, I just got it yesterday. That seems to be one of the main ways to support the Leptos team. So it was an easy decision. Yeah, check out the Leptos store if you want to support the Leptos project. Okay, yeah. So why don't we get started? So let's look at the installation instructions on a Mac. I think they're similar on Windows. Okay. Where are we? Okay. Download now. Okay, so the way this works, I believe, is Modular has a homebrew package. And the Modular homebrew package is like a package manager for Modular. So you'd install the Modular package manager, or whatever you want to call it, and then you would install you'd use Modular to install Mojo. And there's kind of a weird step here. I don't know if they fixed this. There was an issue. Oh, I see. I think they did fix it. But basically, you run this curl command to get the Modular, or you download a script, and the script adds like a homebrew repository, and then it does a homebrew install of the Modular package manager, and then you run Modular install Mojo. So let's check that out. Okay. Okay, yeah. So the script presumably has like a homebrew or a brew update in it. Look at the chat while I'm waiting. Do they promise future compatibility with Python? Yes, that's my understanding. They have a narrative around that already. You have to explicitly import like a certain package, and then you can use like NumPy, which is, if you're not familiar with, that's the canonical kind of package for doing multiplication, matrix multiplication in the Python ecosystem. New language every week. Is this just another way that they crap on devs? I don't know. Their logo suck. I think it's a pretty good logo. I've seen far worse logos. The U logo is by far, like, say what you want about the framework, but this is the most awful logo ever. Sorry if anybody in the U team is on the stream, but this is just no. Mojo's at least C tier or B tier for logo, possibly A tier. Yeah, that's my opinion. Okay. All right, so now we'll do Modular install Mojo. So now we've yes, I already have it. I'm just kind of walking through the installation steps. So yeah, so let's just do Modular update. I don't know why it gives a URL there. No updates. Okay. Well, yeah. So that's what you do. Modular install Mojo. That's all. And so now we have a REPL. You can just do Mojo. I have a directory here, Mojo test. We can just do Mojo, and then we get a REPL, similar to what you get with Python, right? And it actually says outright right here, and I missed it the first time, and I'm like, why is this not working? You can't press enter once to execute a line of code. You have to press enter twice. So if I do print hello, like I expected hello to be output right after pressing enter. You have to press it again. Then it outputs. Like if you miss this explanation here, and I'm ambivalent about whether that's a good decision or not. I can kind of see why they did it. I think there's issues in like the Python REPL where, if you want a new line, if you want to add a new line to the existing command, I think you have to hold down shift or something. I don't know. This makes executing a multi-line command in the REPL a lot easier, but it carries the risk of confusing people, thinking their installation's not working when they first start out. So something to watch out for. Yeah. Okay. So basic operations. And we'll move to the IDE in a minute, but okay. 1 + 1 = 2, right? Variables. A = 2, B = 4. I think if you just, in the Python REPL, this would actually output to the console. I forgot if this actually does. Oh, it does. Okay. So it gives you the type of A and B. And Mojo has your standard types: int, float, string, so on and so forth. What else can we do from the REPL? Yeah, let's move into the IDE actually. Okay, so there's again, I mentioned this a little bit earlier, but if you're joining later, you missed it. As far as I know, the only real way to get syntax highlighting for Mojo is via a VS Code plugin. So that's how we wound up here. If that wasn't the only option, I likely would not be using it. So you can trust that. Yeah, we're not going to break out Emacs or Vim today, unfortunately. Oh, nice. Look at the... So yeah, pretty easy to find. Just search for it. I already have it installed, so that's it there. I do not know how to use VS Code. Like, I want my primaries. Explorer, there we go. Command Shift E. Right. Okay, basic stuff. So I think right now, so I have this file test.mojo, and then I have my terminal open down here that I'll use to run mojo test.mojo. Yeah, it doesn't define a main function. I believe right now you have to define a main function. It's not like a Python file where you can just throw random stuff in the file without a main function and it'll run just fine. So we're going to define function main and print hello. Okay. And I'm trying to remember there was a shortcut for control tilde. Okay. Moving back and forth between the editor and the terminal. Control tilde. Got it. Test.mojo. Cool. And we get what we expect. Now, functions. So I mentioned Mojo is a superset of Python. We can do your standard def do thing. We'll make an add function, A and B. And don't forget your tabs for your indentation. Return A plus B. Add 2 and 5. Okay, control tilde. Return. Oh, oops. Yeah. So normal Python syntax applies. Forgot a colon there. Failed to parse. What is going on? Provide a Mojo. That's right. This is new. Can I not call? Do I have to make this a function? Is that what's going on? And then I tried the Python syntax last time I tried Mojo, and it seemed to work fine. I didn't try it since I downloaded the SDK. So, oh yeah, specify a return type. Use an arrow to specify the return type, and then you still have to have the colon. That threw me off when I was playing around with this. I was like, is it colon return type? And then nothing after that. And yeah, use an arrow like Rust, but you do need the colon at the end of that function signature. And it looks like we're in better shape now. So I don't know what the story is with, if I make this def, can I do def here? Maybe. Yes. Okay. That's what's going on. So maybe it seems like maybe you can't call a function defined with def in the Python style from a function defined as fn in the Mojo style, which makes sense because, so zooming back here. So again, the Mojo mentality is that you have your Python code. You start out by copying and pasting your Python code into your Rust code, or Rust, into your Mojo code. and it works out of the box. Nothing, no changes. That's the vision. But with the Python syntax, there's an upper bound to what optimizations you can apply to that code, because obviously you don't have keywords like borrow, and you don't have types necessarily. So all this is going to add a runtime penalty. And then you would slowly migrate to the Mojo syntax, which there's an example of this right here, right? Where you can add some Mojo syntax to functions that are defined using def, but I think there's an upper bound to, you can't, there's a limit to the Mojo kind of syntax that you can add to the functions defined with def. And there's also a limit to the optimizations that can be applied to that function as I understand it. So ultimately you'd wind up changing this to function. Now, here's a question. Can we call a function defined with fn from a function defined with def? I actually don't know. Looks like we can. Okay. Okay, what now? So this is a simple function. Just look through comment or chat here. Yeah, difference between function and def, I kind of covered that. How do you use mouseless? Use the Vim key bindings. Yeah, there's a Vim key binding plugin for VS Code if you need to stick with VS Code. I prefer NeoVim and Emacs, or Emacs, one of the two. But yeah, I went cold turkey. I went straight to Vim and then Helix briefly, and then to Emacs after that. But probably I had the luxury of learning these while not having a full-time day job. So I imagine if I were doing that, I would probably learn the bindings or start learning the bindings in VS Code, or I was a JetBrains person. And then kind of slowly learn the bindings, and then maybe ultimately switch to Vim or Emacs or Helix. Try accept. Yeah, I didn't venture into exception handling yet. My understanding is that that's implemented, but I don't know. It's not. Maybe I'll take a look at that at some point, but yeah, probably not today. Function instead of function raises after. Okay. Compared to something like nim. Yeah, that's a good question. How does it compare to something like nim? Nim is something I've been wanting to explore and just not had the time. It seems really elegant, and I think it seems like they have a pretty good narrative around performance and memory safety. I was trying to read about kind of the default way of memory management, and I didn't fully understand it. But I heard, I don't know if it's nim or I'm confusing it with a different language, but there's some bleeding edge language that they were going to add Rust style borrow checking to. And this is part of the reason I'm interested in Mojo, is because I actually like the Python syntax and using tabs to delineate scopes. I personally love that. I know many people hate it. I also think the Rust borrow checking semantics make a lot of sense, and it's a small price to pay for not needing a garbage collector. Things get messy when you need to do interior mutability. That's kind of tough, but usually you don't need interior mutability. At least in libraries you probably do, but if you're building a web application, I've never run into a case where I needed interior mutability. And so for use cases like that, it makes a lot of sense. There was a video about this. If you're working with graphs, that kind of surfaces the pain of the borrow checker, because you're forced to use interior mutability basically if you need to modify the values in the graph nodes. Anyway, that's a tangent. Okay. What's next? Open up my notes here. Action main. Okay, we did that. Okay. How are we doing on time here? 25. Okay. I mentioned this has Rust style borrow checking. But the difference is Rust by default function parameters will be owned. So they'll be moved. If I were to call, if this is a Rust program and I called add, and if it was an integer, it would be copied. But forget about that for a second. If we're calling a function with and passing in a structure of some kind, it's going to by default move that to that function, and that variable will no longer be usable from the call site or in the function that called it. Mojo kind of flips this on its head and makes borrow the default. So, and the other thing, the syntax for this is much different. So if I want to, let's make it, this is a good time to demonstrate structs, I guess. So struct thing, and then we have, I'm trying to remember, I can't remember the syntax right offhand. Word. And then, I don't know, int. And then we do have to, there's ways around this, but let's start with this. You do have to define a default. It does not generate a default constructor for you like a lot of languages do. So you'd have to do function. I think it's, the syntax is, I fully anticipate making a bunch of syntax mistakes, so bear with me, but, and does this take self? I can't remember. And then int. And then you have to do self. Oh yeah, it does take self. I believe that's similar to Python. Word equals word, and then self dot num equals num. So this is, if you don't annotate the struct with anything, this is what you have to do. Let's make sure this works. Why is this? I'm doing something way wrong. All right, it's time to bust out the docs. Language basics, that's pretty much where I'm at. Okay. Oh, do I need var? I need let, I think. Is it? Structures. Yes, I need let or var. Okay. I'm going to do var. So just like let means the variable is not mutable. Var means it is mutable. I think, what's the analog? I guess the analog of that is JavaScript or TypeScript. Yeah. And then we don't need the commas, I believe. What's wrong with self? Oh, in out. Okay. So in out means, in out is the equivalent, I think, of a mutable reference if we're in the Rust world. So this is the equivalent of doing at mute, like that, I think. I don't know how many of you are in the US, but we have a restaurant called In-N-Out that sells burgers. It's a fast food restaurant. Every time I see this word, I think In-N-Out, and it makes me hungry. But yeah, that's a separate story. So let's try to instantiate this. And I believe we can just pass a string literal. And I forgot what it will do if we just try to print. That's not gonna let me do that. Or from thing to string. Okay. I don't know how to print the entire struct. I'm sure there's a way to do that, but let's just print the individual fields. Okay, let's try that out. Hello to, yes. Okay, that worked. So that is how you define a struct. Pretty straightforward. I believe there's no, I wanted to do an example with a graph or a tree or something. Yeah, that's right. And I don't think recursive data structures are supported yet. So if I wanted to do left and make that a type thing, I think that'll, is it letting me? Okay, I'm not sure about this. Okay. Maybe that's the issue I ran into. So maybe recursive structures are supported because I'm not getting a compile time error. Can I do self.left equals thing? Well, I would need it to be an option, I guess, because yeah, let's save that for later because I haven't ventured down that path yet. There is a way, I believe, to get this to generate the default constructor automatically. Oh, okay. Houston Bova. So if I do this, and then this returns a string, right? I can do, just for testing's sake, I can do this. Oh, self.word. No? No, attribute toString. Oh, well, sorry. I can just do this. So if I do, now if I print thing, will that work? Wait a minute, what? Why is it complaining about add? Kali expects 2 input parameters, but 0 are specified. I don't know what's going on. To print full struct. Yeah. Thing to thing to, oh, I see. Like that? Yeah, I don't know. Okay, let's go back to there's an annotation. I forgot what it's called. It's value. I think you can add an annotation called value on the struct, and that'll auto generate this stuff. Let's see if that works. Yep, looks like it does. So it makes it in Kotlin, the equivalent is like, what's that called? A data class or something like that. So if you do @value, it'll automatically generate the constructor. And I think it generates some other stuff too, because there are situations where you have to write a move constructor and a copy constructor. If you're familiar with C++, you'll know what a copy constructor is, but basically they're functions that allow you to explicitly specify the logic that gets run in these certain situations where things are moved or copied. But let's try passing thing to a function. And then we'll see the kind of the borrowing semantics. Oh, is this the reason why? That might have been the reason. I'll try it later. But we'll do something and then thing. Print thing. .word. Okay. So we're printing thing.word here. Let's call do something, and that's pass thing into do something, and that's just going to print hello. So we should see, yeah, we see hello twice, right? Now let's try modifying thing. Let's do thing.word equals world. Immediately we get a compile time error. Expression must be mutable in assignment. So we could do in out here. We could go the burger route. But yeah, we still need to define in main, this is just like Rust. Instead of let, we need to do var. And then I think this should work, right? Yeah. And so do something changes the world, and that change apply. We know it's not copied because that change still has effect when we call print in the main function. Yeah, so that's in out. Let's try, I mentioned default is borrowed. So yeah, you get an error whether you have that word or not, obviously. And then the other one is owned. So in this case, I would expect thing.word to be, that's interesting. Thing was declared var but never mutated, consider switching to let. So that's a warning, I guess. And we get with that. So it looks like okay, so it copied. In Rust, you would get an error, right? You get an error on this line, printing thing.word. And you would say ownership is moved in this call to do something. So it seems like instead of it's moving the thing to do something, but as it's doing that, it's copying it and keeping it in the main function, I guess is what's happening. I don't know if anyone knows exactly what's going on here, let me know. Yeah, that's interesting. But let's try, I know there's like this caret thing that I didn't fully understand. Okay, so so I think this makes it so it's not copied. If you pass something to an owned function, if anyone from modulars in the chat, please feel free to set me straight here. I don't want to miscommunicate, but it seems like when you put the caret, now it's moved to do something and not copied. This is interesting. So the function can specify that it needs an owned type, or it needs an owned value. It doesn't care what the original caller, how the original caller gets it that owned value. So then the caller has this, the more I think about it, this kind of makes sense. Because yeah, the caller can decide whether it wants to copy. And in Rust, there's a pattern where you do this explicitly, right? You'd clone the thing before you pass ownership to the function, and then you could use the clone in the function. This seems more concise. It's just a more concise way of doing let thing2 equals thing.clone in Rust, and then using thing2 down here. That's the way I'm understanding it. That could be wrong, but if that's the way it works, I actually really like that. I think that's cool, because this gets verbose, and it seems like at least there's a lot of scenarios where you need to do that, or you need to leverage that pattern. So having a concise way to express it might be nice. Okay, what's next? Fearless concurrency. I haven't delved into concurrency. I'd be shocked if there wasn't a narrative around that. Yeah. Okay, I think we're going to look at strings next. And when I tried Mojo out last time, I couldn't even do what I'm about to do now. So things are clearly progressing. How are we doing on time? We got 20 minutes. Okay. I'm going to write a palindrome checker. Yes, it's a silly problem. Nobody cares about writing a palindrome checker, but it's a good way to demonstrate kind of the string functionality. So we're going to do let auto equals auto. Let Hannah equals Hannah. There's a kid's book with those two names that I remember from childhood. Thing equals thing. And then so we want to, our palindrome checker is going to return true if it's a palindrome, false otherwise. Pretty simple. Is palindrome auto. Oops. Okay. And we should get true, true, false, right? So function is palindrome, and it's going to take a string and return a Boolean. We need half the, so the idea here, I think most people have probably seen this problem before, but you iterate up until like half the length of the string. And there's this corner case where it works slightly differently if the number of letters in the string is even, and let's do one with an odd number of characters. I don't know, Ava. I think that's a name, right? Just to make sure that case is covered. And so you iterate up to halfway through the string, but if it has an odd number of characters, you don't have to, obviously you don't have to check that middle letter because we already know it's a palindrome. So you divide the length of the string in half, and if it's a fraction, you can just take the floor of that, because the only way it would be a fraction is if it's an odd number of characters, and you need to check up until the middle character. So it's an example in the C++ world. It's an example where casting from a float to an int is actually desirable because you just chop off the fraction. Anyway, the half length, and this is going to be a float 64. For some reason, the default type that comes out of a divide is float 64. It's not a regular float. I don't know the story behind that. And we're going to do a for loop. We have range, kind of like we do in Python. And we're going to go to from 0 to half. And then casting to an int. So I think casting in Python would be like, casting in Python, let's exit out of here. Run tmux. See, this is Python. Got to name your windows here. Oops. So 5. Yeah, that's how you cast in Python. So that, I'm pretty sure that doesn't work in Mojo. Let's run Mojo here. So the equivalent of that would be what? Int 2.5. Yeah, cannot construct int from float literal. But if we do, can we do 2.5 to int? Yes, but it doesn't output anything. Let a equals 2.5, and then a.to int. What about that? What? Why is it not casting? Okay, well that works. But it, yeah, anyway, okay. So casting is .toInt instead of int and then put the thing in the parentheses, right? So we're gonna do, so we can index into a string using square brackets. If a of I equals not a of length of a minus 1 and then minus I, right? We'll return false. Okay, and then if we get to the end, that means it is a palindrome, so we'll return true. Super simple. Why is this giving me expected in after target modifier? What? Oh, yeah. And this needs a colon. That looks right. Cool. Okay. So you can, I don't think this was possible before. I could be wrong. But yeah, you can actually start kind of building stuff now. Obviously, there are things that are not implemented yet, like glaring omissions, right? If I wanted to make a dictionary, that is not going to work. Cannot emit dictionary literals yet. And as far as I understand it, there's no analog to dictionary in the Mojo world yet. So that's a pretty big damper for a lot of algorithms. I think there is a hash map, but the syntax is nothing like Python dictionaries. And the syntax of Python dictionaries can be pretty convenient. What else? Okay, so we could talk about SIMD. We got 10 minutes. Any questions about this? Obviously, we haven't gone too deeply into Mojo. There's a lot more to cover. This is kind of like a surface level check-in on how development is going. And it seems like there's definitely progress been made, but it does seem like the team is definitely optimizing for that kind of low-level matrix multiplication world that a lot of us don't live in. That probably makes sense. I have high hopes for Mojo. I don't know if you guys know about this, but they have a pretty significant backing in terms of investment. So it's not telling me the funding amount. Last I looked, they have 30 million in funding. So I suspect that gives them a pretty substantial runway. So it's kind of hard to imagine this going south anytime soon. So I'm really excited to see how this develops. If I were to cover something else, let me know what you want to see. Do you want to see more like matrix multiplication stuff? Yeah, I don't know. Do you want to see kind of how the language progresses as they implement parity, as they get parity with Python functionality and syntax? Do you want to see more of that, like leak code algorithms? Yeah, let me know what you want to see. Let me just take a quick look at the chat here. Brian said let. Yeah. How about you compare? Yeah, that's probably true. Radar. Okay. Take a look at the manual real quick here. Kind of the bread and butter of Mojo is SIMD. So, and I haven't delved too deeply into this, but essentially SIMD means simultaneous instruction, multiple data, I believe. And the idea is, and every processor has, or modern processors have some kind of SIMD functionality where you can put an array of a certain size on a register and then another array on another register and do a multiply of those arrays in one go, in one cycle. But the sizes of those registers vary across hardware. And I think one of the goals of SIMD is to kind of abstract that away from the developer. And so it kind of does the optimization for you. You make a SIMD of whatever size you like. And this could be wrong, but my understanding is that under the hood, it's actually optimizing for your specific hardware. So that's kind of cool. And SIMDs work kind of like normal arrays. I don't think they're mutable. But yeah, maybe I'll go over those next time. I think we're just about out of time. Thank you all for joining. This was pretty fun. I have a couple minutes if anyone has any questions. Yeah, how many libraries and frameworks are available at this point? No, there's nothing. There's no libraries or frameworks, as far as I know. That could be wrong, but it's still very early stages. Took me a lot of tries. Okay, cool. Well, thank you everyone for watching. Let me know if you want more live streams. Let me know about topics. Let me know. I could do like a walkthrough of my Emacs setup. That's kind of a video I've been wanting to do for a while. Yeah. Anyway, thanks everyone for joining. Is compilers in place? Is it specific to AI? It's marketed toward AI developers, but if their vision comes to fruition, there's no reason I don't think it can be a general purpose language. Yeah, but that's kind of the niche they're targeting to kind of get their foot in the door. And their logic makes sense. It is an area of need. Like I said, the Python ecosystem kind of accepts that Python's slow, and I know there's Julia and there's some attempted solutions to that problem, but then you also have the language fragmentation where you have the underlying libraries written in C++ or C. I actually interviewed it for a position one time. This is a long time ago, but I interviewed for a position at a company where the role was specifically so there's some machine learning PhDs at the company who came up with algorithms, and they wrote their algorithms in Python because that's the go-to in that world. And the role that I was applying for was specifically to translate those Python algorithms into C++. So it's a testament to two things. It's a testament that there's a need to write things in C and C++ instead of Python. I think everyone kind of knows that. And it also is a testament to the fact that like a world-class machine learning researcher might not necessarily be able to delve into that C world. Like the overhead is too high for them to learn and kind of master that language. So because of that, language isomorphism or homogeny across your entire stack seems like it would be very valuable. And it's a very real problem that I think Modulars is attacking here. And it's a tough problem. How do you get, and I think they're approaching it the right way. It's hard to imagine a language that aims to solve these problems succeeding without being a superset of Python, right? I think deciding to make this a superset of Python is the kind of killer feature that will allow this to gain industry traction. So I think I probably wouldn't have quite as much interest in it if it was not a superset of Python. But yeah, I think they're doing the right thing. So I'm excited to see where things go from here. My go-to language these days is Rust. I know I haven't made a lot of Rust content recently, but there's plenty more coming. Yeah. Cool. All right. Thanks everyone. See ya. I think there's actually a modular live stream at 11, if I remember right, unless they changed it. So maybe check that out. I would like dump you all into there if I knew how, but I'm new to this. So, all right. Bye, everyone.